This is a short video of C++ programming, and in this video we gonna talk about function. So let's first define some function, just a simple addition function. Yes. So how we gonna do that? We have to first define a returning type. I will explain about it more later. So yeah, first we put the returning type and the name of a function. We name it at in this case, and in this parenthesis, we gonna put parameters that we want to pass into this function. And yeah, in this case we need yeah, parameter x, and we put another bracket, and in this bracket we can write anything that we want to do in this function. And this add function basically do an addition, yeah, x plus let's say, yeah, 10. So this function add 10, yeah, to the given x, right? Yeah, given x, and it uh, re returns x, yeah, again. Okay, so well, yeah, I will explain about the structure of function in detail now. So as I said, it's a return type. So here is return. So whenever we call um yeah, except for one case, whenever we call a function, um we have to return something, right? And this returning value x is, it's integer, right? Integer. So x is integer. So we're gonna return an integer value. Yeah, an integer value x, right? So that's why I put int here, because returning the type is integer, right? Yeah. So and when we call a function, yeah, we can pass some parameters. Yeah, we can add, yeah, parameters, of course, like more parameters, more than one. So yeah, if you want to add another parameter, float y, yeah, we can do like this, and you can do whatever you want in this function. Yes. um, but you should know that you can return only one variable. Yeah. So this is how you define a function. So how you gonna use it? It's quite simple and straightforward. Um, Let us define integer value a equals 1, and another oh, yeah, we're gonna define another integer value b, but this b is given by uh, passing variable a to add function. Yeah. So yeah, you use the function like this. Let's say, yeah. So you pass a integer variable a to function add like this, and it returns integer value x, right? So this is this will be replaced with variable x, yeah, right? So what we're gonna get is, because a is 1, we pass a to here, and this is x equals 1 plus 10, so it returns 11, and we get 11 here. So b should be 11, right? Yeah, so okay, let's see how it really works. Just a moment. Yes, so let's see the result. But before that, we have to compile it. We compile function. Oh, it's function.cpp, and we want executable uh, file, named function, and we got function.exe. Now we can run it. Yeah, as you see, a equals 1 and b equals 11, as we expected. Yeah. Okay, great. So this is the the basics of function. Yes. So now we're gonna talk about we're gonna talk about overloading. It's a bit advanced concept of function, but it's good to know. Overloading is defined. It means tajutegi in Japanese. That means defining, um, defining multiple functions, but using the same name, right? So I will show you. So now we're gonna define a function of returning type float, and the name is exactly the same as the one above, right? Because it's yeah. And now we get a parameter, um, yeah, of float, x, and we write something a bit different. The other one, x, yes. So you see, the name is the same, right? So when you call a function, because the name are the same, that means it's a bit confusing, right, for the computer, because we own you know both function are named as add, right, and we just call add. So how we gonna differentiate those two functions? It's the compiler does it quite a smart way. We pass a parameter, right? And in this case, we pass an integer value. So when we pass integer, compiler knows that, okay, the programmer wants to use the above function because parameter is integer. And so if we change the parameter a into a float value, then the compiler knows that, okay, then he's gonna call this function with float parameter. Yeah. So in this way, um, we gonna sometimes do overloading, and the reason why we need it is because if you want to some flexibility of the input, so you don't know if the user put some integer number or floating point number, then you just define um, two functions with different um, data types, right? So you can accept both integer value and also floating point value, right? So that's how you use it. Okay, let's just try um, with this setting, this case, and let's see what we're gonna get. Yeah, cool. So it's not quite um, good example, I guess. Yeah, this way we know if this function is called or this function is called. And let's try once again. And yeah, you see float is called. So in this case, um, this function is called, yeah, not this function, because the input parameter is float. Yeah. Okay, I hope it's all clear. And the final concept that we're gonna cover in this video is also a bit, yeah, a bit advanced, I think. Change it to integer again. And yeah, what we gonna do is now use reference. I think some of you may know about reference in C++. So, so how does it work? Um, I'm gonna change the function a little bit. So I said in the beginning of this video, there is one exception of the dead type, right? And that is um, void. Yeah. So void means nothing. Yes, nothing, literally. So that means you don't return anything. Yeah. If you don't want to return anything, then you should put void in the dead type. Yeah. You can't define a variable of void, but you can define a function of void. Yeah. And um, so so if we define a function as void, then that means it doesn't return anything, right? So even though we call add function here, it does not change anything in the main function, right? Yeah, let's just see how what's gonna happen. So here, so in this stdc out, it just output a equals 1, which is defined here. So even though we do some calculation here, it doesn't change anything, right? Right. So um so now reference comes in. Yeah. So um reference is um I would say it's aliasing. You add another name for a variable. Yeah. So you add you can give another name for a variable, or you can share the variable, I would say. So how you gonna use the reference is sorry, you're gonna add here and this first. So how you define a reference? Reference, you can define a reference like this, right? You see what you see, and yeah, just forget about it. Just forget about the function. Yeah. So you define a reference like this: int and then b equals a. This means b is a reference of a. So um, um, we're gonna change b a little bit now. Plus 2. And because b is a reference of a, this makes an interesting behavior actually. Yeah, you see now a equals 3 even though we didn't change a explicitly, right? That because b is the reference of a, so b and a are the same, or I would say, yeah, they are the, I mean, it's not the copy of A, yeah. B is not the copy of A, but uh, A and B are different names, but um, pointing to the same variable, yeah, I would say. So if you change B, then that means A is also changed. If you change A, then B is changed, yeah. So this is the reference, and we can use it when you call our function. In this case, you pass a, right, and you do some calculation, and um, if you make this parameter as reference, then what's gonna happen is that because x is now reference of a, what um, every change that happened to x also happens to a, even though they are in different functions, but yeah, but still valid, yeah. So if you change x in this function, a is also changed exactly the same as x. So let's see what's gonna happen. So now you see, we pass a equals 1, and here x becomes 11, right? Because we add 1 and 10, and even though we didn't return anything, but due to the reference, a became also 11, yeah. So one, I mean, it seems like it's a bit nonsense, why we use reference, when you call a function, because we can use the first one, I mean, returning type of integer, and you can return um, the value from the function, and you can still get some result from the function, right? But the reason or one benefit of using a reference is um, um, yeah. So as I said, referencing is not copying. Yeah, copying means you make you know um, a copy, so another entity of your variable, right? So you duplicate it. But referencing means that you don't make any other entity, but you just give another name to the same variable. So if, let's say, the parameter is quite huge, I mean huge data, yeah. If the parameter is huge data, then creating a copy of that huge data is quite expensive. Yeah. So, but if you pass the reference, only the reference of that huge data, you don't need to duplicate that, big data, and you can just, pro um, um, yeah, um, use that same variable from another function, right? So that's quite beneficial in terms of the computational um, cost. Yeah, um, that that means it makes the computer works faster. Yeah, and and avoid any um, um, yeah, memory intensive operations. Yeah, so that's I would say that's the main case that you should consider about using reference when you call a function. Yes, so that's all for today, and I hope everything is clear um, about the contents that we covered today. If you have any question, please leave it in the comment, and yeah, see you again in the next video.